Okay, good. So you can see that we're missing one unit, right? Do I have a unit to put there? This is me asking y'all. So type it in the chat, right? Do I have a unit? Yeah, I have 4, right? We can see that 4 there. So I'm going to grab one and I'm going to put it there. Bam. So what does that mean? I just completed my square. Well, how? What did I need to complete my square? Well, that's right here. I needed an x and then a -1, right? Because this is a negative x and this is a negative x. So -1 times -1 is a +1. So what happened to the leftover? Which actually one of you noticed that, right? Whatever was left over was always outside of the parentheses. So one of you made that observation. Okay, good job. So let's go to the next one. Let's do another one. Again, so we have 1x squared, we have -6x, and then 12. So if I have 6 of these, yeah, they're all negative, right? But I have 6 of them. How do I know how many I'm going to put here? What do? You have 6 of them. How do you know how many are going to go there? How do y'all figure that out on your head? How could you figure that out without type it in the chat? So how do y'all figure that out? Okay. Okay. All right. So some of you use the shape, right? So, and okay, so here's some of the things y'all are saying. You want it to be equal on each side. So in order for it to be equal, one of you said that you're going to divide by 2. Well, that makes sense, right? Because you want the same amount here to be here because it's a square. So I'm going to move these, and one of you noticed that the shape helped you, right? The shapes that it was facing, right? So there you go. Now, what does this mean? Well, you have 3 negatives here, 3 here. So how do you know what's going to go here? How many units? How many units are going to go here? Okay. So let's see. So a lot of you, I'm getting 2 different numbers. Okay. So let's see if you're right. Let's start filling it in. So we have 1, 2, 3 there. Let's keep going. And if you change your mind at any time, feel free to fix it in the chat. So how could I have gotten 9 without just filling them in? How did we get 9? What 2 things did you multiply? How many x's do you have here? 3, right? -1, -2, -3. How many do you have here? -1, -2, -3. So what did you do to get 9? Or what did some of your classmates do that got 9 the first time? What did they do? Okay. And again, someone made an observation earlier, right? That whatever's left over is always out here on the outside. Do you see that observation that y'all's classmates made, right? Okay. Next. So here, right? So how many units do I need? Type it in the chat. I should see 11 responses, right? So 1, 2, 3, 4. We have 4 people. 5 people. 6. So that's more than half. Where's the other half? I'm gonna start calling all out. And remember, I'm recording on session. There we go. Okay. Now, do I have 1 unit to put there? We do. What is this number that I'm moving around right now? Is this a positive 1? No, right? We can't have, we want a positive. And how do we know it has to be a positive? Because this is a 1, right? It's green. So 1 times 1 is a positive 1. Do I have a positive 1? No. So what does that mean? Adding unit 0 pairs as necessary. This is a 0 pair. Can y'all guess why? Because 1 minus 1 is 0, right? So what does the number 0 mean? Am I really changing anything? No, adding 0 to anything means that it's still staying the same, right? So I'm going to grab this unit pair and I'm going to put it right there. What happens? My square is now complete. So what does that mean? That means that I started with -2, right? So in order to complete my square, we can all agree that I needed 1, right? But did I have 1? No, I was at -2. So I had to borrow 1 in order to complete it. But if you borrow 1, that means you owe 1. Does that make sense? So instead of -2, you now owe 1 more. So we're at -3, right? Okay. So let's go on ahead and go to our, do we need to go to the Nearpod? Let me see here. Yes. So remember the questions I asked you to keep in mind, okay? Because we're about to fill in our notes. What patterns did you find? What was being rearranged and moved? How do you know what value is necessary to complete the square, as in, where does that number come from? Do you always have enough units to complete the square? And what happens if you do not have enough units to complete the square? Now we're gonna go on ahead and do our notes, right? So this is really for the asynchronous people. They're gonna have to go watch the video of me teaching, right? Okay, so now go on ahead and take out your notes. And hopefully today we're gonna be making more sense of why we do what we do. Okay, let me share my, okay, so lesson 4.8. Remember, the whole goal, right, what we've been doing for the last few lessons is that we're solving quadratics. What does that mean? It means you're finding the x-intercept. So all I've done is that I've given you different methods to do the exact same thing, which is find the x-intercepts. So reminder, completing the square really just means that we're going from standard to vertex form, right? So that should start to make a little bit more sense after today's activity, right? Because a square is the same thing, but multiplied by itself, right? So here's your steps that you can use. As we do the examples, we'll talk about and we'll run through it, right? And we're also going to be talking about the equations we use and why they should make sense now, or hopefully make more sense. Okay, so example 1. Okay. So for example 1, where's my filled in notes? Sorry. So we're gonna start by drawing little units of our own, okay? So let's make a key of what everything is going to represent. I told you last class to bring 2 different colored pencils or pins. This is the reason why. So we're gonna make our squares, make them x squares, right? And we're going to make, I'm gonna use green for positive x's, just like the activity did, right? So any vertical or horizontal line is gonna be an x. And I'm gonna use red for my negative x's, okay? So any vertical or horizontal line I draw is gonna be a negative x. And my units, I'm gonna make into dots because I don't wanna draw a whole bunch of little squares, and a dot would be easier. So these are gonna be my 1 units, right? So each little circle is worth 1. So for this first one, we're gonna find the solutions of the quadratic functions by completing the square, okay? So we can see that it's equal to 0, which is exactly what we want. Now, what did we do in the activity? Okay, so we have 1x squared, so I'm gonna go on ahead and draw that, right? So I have an x squared. So what does this mean? What color am I going to use for this negative 6x? It's a negative, right? So I'm going to be using red, not green. How do I know how many are going to go on each side? What did we do? What did we decide earlier? What are we going to do? Type it in the chat. Okay. So those of you that aren't seeing it, well, let's just draw it, right? If I'm going to draw this, I know I have negative 6 of them. So I'm going to draw 1, 2, 3, 4, 5, 6. So what did we end up doing? We ended up splitting them between two places, right? So what did we really do? Well, we divided by 2, right? Because that's what Edie said. So we divided by 2. So we grabbed my x's, right? The one that's just the x term, and I split them between 2 spots. Now, how do I know? So what do we have so far? Well, in order to get x, we know what that is. That's x times x, right? X times x is x squared. So how many do we have here? We have negative 3 there. And how many do we have there? We have negative 3 here. Where did that come from? By dividing this by 2. So is everyone following along right now? Right? So how many units am I going to need here? Without having to fill them in, right? I could just fill them in, but how am I going to figure out how many I need? What would I do? What am I going to do? Type it in the chat while I fill them in. But how do we get that number? So some of you are telling me, well, it's 9, but how? What did you do? There you go. Okay. So if you notice in your notes, step 3 is to find the value needed, right? In order to complete the square using this formula. Maybe now, or hopefully this formula should make a little bit more sense now, because it's literally exactly what you just got done doing. What did we do? We grabbed B, which was negative 6. We split it between my 2 sides. And then how did I get the number I needed? Well, I squared that number. So you got negative 6 divided by 2 and square that. Well, what's negative 6 divided by 2? It's negative 3. Do you see how that's the number we have here? So that's negative 3 and negative 3 squared, which is what y'all typed in the chat. Negative 3 squared is where I get 9 from. So in your steps, now does it make sense as to why we put parentheses around this right here, right? Because this is what we're grabbing to help us form our square. And this is what's going to help us determine how many units we need to make that perfect. Okay, so what have we figured out? We know that we have x squared minus 6x. In order for this to be perfect, I need 9 units. Okay, where did we get these units from? Where did we take them? Where did we get them from? Is there somewhere I can take them from? Where do I take them from? Type it in the chat. Where do I get them from? Where are those 9 going to come from? Exactly. Okay, so I'm waiting for more of you to see what I'm talking about. So where are these 9 units going to come from? Where am I going to get them from? Think of the activity, right? Where did I get those units from to fill it in? There you go. So that's a few people that have responded. I'm waiting for a few more. So that's, I'm still waiting. Don't make me start calling y'all out. So here's what we have, right? Here is my original. Pay attention to the original. How many units do I have to start with? I have 25 of them. I need 9. Can I just take it from what I have? Absolutely. So if I need 9 in here, that means that we're going to take away 9 from what I already have. So do we see why we have to add your perfect square and at the same time take away, right? Because what's 9 minus 9? 0, right? Because we don't want to change our equation. We're just manipulating it to make it give you a perfect square. And then if we have leftovers, that's fine. We can have leftovers as long as they're outside my parentheses, right? So we know we need 9. So that's in here. This is a perfect square, right? So what's 25 minus 9? We end up with positive 16. And we already know what my perfect square is, right? It's right here, x minus 3, x minus 3. Where did the minus 3 come from? B divided by 2, which is this number. So your perfect square is x minus 3 squared plus 16 equals 0. You just completed the square. Now remember, the whole goal and the purpose of this is to find the solutions, right? So to find our solutions, we're gonna use square root method. How do I know I can use square root method? Because from yesterday, right, we can use square root method if we have vertex form, okay? So that means that we're gonna subtract 16 from both sides. So that's negative 16 equals x minus 3 squared. Now what do? Because this is the only x I have and it's squared, I can square root it. So x minus 3 equals a positive or negative square root of negative 16. But can I take the root of a negative number? Not yet, not until after the break, okay? After the break, we're gonna start talking about complex numbers and this will be possible. I'm gonna show you how to do that. Today, you don't know how. So my solutions is no real solutions because you cannot take the square root of a negative number yet. Not yet. You don't know how yet, but you will. So, example 2. Do y'all want to draw your model first on your own? I'm going to give you a minute to draw your model, okay? So let me pause the recording. Y'all, don't forget to tell me to unpause it, okay? Because I need it. So pause recording. All right, so you should have seen that we have 1x squared, so you should have drawn an x squared, right? And how do we get x squared? Well, we know that's x times x, right? That's the easy part. We have positive 8x. So how many did you put on each side? Type it in the chat. This should be quicker because y'all should have already done it. And I should see 11 responses. 1, 2, 3, 4. Keep going. 5. Okay, I'm gonna start calling out the people that haven't typed it in. 1, 2, 3, 4, 5. Good. 1, 2, 3, 4, 5, 6, 7. That's 7 people. That's about a little more than half. Who am I waiting on? So what did you do with the 8, right? How many did I need on each side in order to complete the square? That was the question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing 3 people. Who are they? I'm about to figure it out. 2 people. Ava, you're one of them. And Fatima, you're the other. Ava and Fatima. Ava, Fatima, you're the people I'm waiting on. Where are y'all? Okay. So remember, right? If I'm trying to make a square, I'm going to draw these 8 so that they're evenly distributed, right? Because that's what a square is. It's even on both sides. So if this is 8, I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8. So how many did I get on each side? 4. So what does that mean? That means that I need, so this is plus 4 and this is a positive 4. So 4 times 4 is 16. So I'm going to need 16 units. I don't feel like drawing them. I'm going to need 16 little units there. Where did this come from? This should make sense with the formula now. Our formula is b divided by 2, and that's exactly what you did. You grabbed your 8 and you split them into 2, right? So that was 8 divided by 2, which is 4, and 4 squared is 16, which is the number you need to complete the square. This is what you used, right, to figure out what you needed. So we know we're going to have x squared plus 8x, and we need 16 units to complete that. Do I have 16 units to put in here? Do I have 16 units? I have negative 33. So no, I don't have 16 units, which means I'm just going to have to take away another 16. That's still not going to change, right? If you need 16 here, you're still going to have to take away 16. That just means you're going to be more negative. Here, this was a positive, right? So I was able to take it from here. Here, it's a negative. Oh, well, I don't care. You're still going to have to take away that number. Now we can form our perfect square, and we can see that from here, right? So whatever number is in here. So you're going to have x plus 4 squared. Negative 33 minus 16, what is that? Negative 49. So minus 49 equals 0. Remember, the point of doing this, right, is to solve. I want to know my solutions, my x-intercepts, my roots, my zeros. So from here, I'm going to add 49 to both sides. So that's 49. X plus 4 squared. Because this is squared, I can just undo that, right, by using the inverse of square root. These will reduce to x plus 4. What you do to one side, you do to the other. And we had a conversation about this the other day. 49 can come from 2 different places. It can be a positive 7 or a negative 7. Do not forget that part. That's going to be the part that messes y'all up if you get this wrong. It's because you're going to forget about the negative. Because I can have 2 different answers, that means I'm going to have to split. So x plus 4 equals 7. X plus 4 equals negative 7. Subtract 4, x equals 3. Subtract 4, x equals negative 11. There is your x-intercept. Okay, so let's try it again. So here, what's wrong here? What do I need to do here? Exactly. Thank you, Edie. The rest of y'all, what's wrong here? What does it have to equal? So that means that I need to rearrange this to make it equal 0, right? So we're really going to have x squared plus 16x. Subtract that, so minus 9 equals 0. Now, go on ahead and draw your model and get as far as you can with 2 minutes. 2 minutes. Okay. Okay, you have about 20 more seconds. Okay, so let's go ahead and start drawing our model. Okay, so you should have an x squared, right? Okay, how many x's did you put on each side? Type it in the chat. It should go quicker because you should have already done it. 11 responses. 1, 2, 3, 4, 5, 6. So that's about half of you. Where's the other half? Where's my green pen? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing 2 people. Who are they? There's, you already, oh, okay. Oh no, you had already responded. So I'm still waiting on 2 people. Okay, so here's my x's, right? So I need to split this off evenly. So you should have had 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 plus 8 is 16. So what does that mean? How many units were supposed to be in here? In order for this to be a perfect square, how many should I have in here? Type that in the chat. Right? And again, where did we get that from? Right? This is positive 8. This is positive 8, which is why we use the formula b divided by 2 squared. Your b is 16. Divide that by 2 because that's exactly what we did here and square it. 16 divided by 2 is 8, which you notice is the number that's here. Square it, that's the number you need to complete it, which is 64. So we now know, this is why we put parentheses around that part. So we're gonna have x squared plus 16x. In order for these to be perfect, I need 64 units. Where am I gonna get these units from? Well, I need them from this person. They don't have it. I don't care. I'm still gonna take 64 units because I need them. And then you simplify. So you're gonna have x squared. Remember, this is a perfect square and it came from here. So x, oops, my bad. That's not supposed to be squared. My bad. X plus 8 squared. There we go. 64. So we have negative 9 minus 64. That's going to be a negative. So minus 73. And remember, the whole reason we are completing the square is because I'm trying to find my solution. So then now we're going to use this to solve. So we're going to add 73 to both sides. So we're going to have 73 equals x plus 8 squared. Because it's squared, I know that I can just take the square root of each side. So we're going to have x plus 8. 73 is not a perfect square. It is an ugly number. So I'm going to leave it as an ugly number. So we're going to have a plus or minus square root of 73, whatever it may be. Because I have a positive and a negative, that means that I'm going to have x plus 8 equals a positive 73, square root of that. And we're going to have x plus 8 equals a negative square root of 73. So to find my x-intercepts, I'm going to subtract 8 from both sides. So x equals negative 8 plus square root of 73. And yeah, I'm going to leave it like that. Subtract 8. So that means I have x equals negative 8 minus square root of 73. And this is my other x-intercept. The reason we leave it like that is because if I were to type this in the calculator, right? First of all, that's an ugly number, right? So -8 plus square root of 73 gives me 0.54400374453. And I don't even know if that's where it ends. It's a really ugly decimal, and we do not like ugly decimals. So we're going to leave it like that. And 73 is a prime number, so I cannot simplify that radical. Or at least I think it's a prime number. Hopefully I'm not wrong. 73, I think it's a prime number. Hopefully it is. Okay, next one. We good here? Can I move on? Everyone got that? Yeah, okay. Example 4. So, hopefully you've noticed that it's getting a little harder as we keep doing examples, right? So, example 4, right here in red. If a is not equal to 1, then the coefficient of x squared must be divided out so that it equals 1. You cannot complete the square if this is not 1. Because this is not 1, I'm going to divide everything by whatever that number is. I don't care if it factors out pretty or not. If you are going to use a method of completing the square, you have to factor out whatever this is, okay? So I'm going to divide everything by that number, which is 2. And obviously 0 divided by 2 is still 0, right? Okay. That means this 2 is going to be out here. And I'm going to use brackets instead of parentheses because it looks nicer. So 2 divided by 2 is x squared. 8 divided by 2 is plus 4x. Negative 10 divided by 2 is minus 5. So lucky us, all of these are even, so it looks pretty, right? So that's good. Equals 0. This is what we're going to be using to complete the square. This is what I'm going to be looking at right here. This 2 is, we're going to leave it there for right now. We're not going to use it until later. So right there. So that means let's go on ahead and draw our model. We have, yeah, I did do that. So we have an x squared, right, which we know is x times x. We have 4 units, right? So we're going to have 1, 2, 3, 4. Which means we're going to need 1, 2, 3, 4. 4 dots to complete my square. Remember, this is what we're looking at, right? This is what we're going to borrow from if we can. And remember, this is really just us using the formula b divided by 2 squared, which was 4 divided by 2, which was really 2 squared, which is 4, which is where we got this from. So we know that to complete the square, it's going to be x squared plus 4x plus 4 minus 5. How many do we need to complete the square? 4. So I'm going to take away 4 from what was already given to us. So my factors to make this happen is going to be x plus 2. And where did that 2 come from? Right here, because we know that's what we needed to complete my square, right? 4 divided by 2, right here. So that's squared minus 9. Negative 5 minus 4 is negative 9. Equals 0. Now, don't forget, this entire thing is in my brackets, right? All of it. All of this is in my brackets, which means my 2 is out here. So to solve, right, we can divide everything by 2. So we're going to have x plus 2 squared minus 9 equals 0. Because 0 divided by a number is always going to be 0. Check. Add 9 to both sides. So we have x plus 2 squared, square root, x plus 2 equals a positive or negative square root of 9, which happens to be a perfect square, so that's 3. So we have x plus 2 equals a positive 3 and x plus 2 equals a negative 3. So subtract 2 to both sides, x equals 1. Subtract 2 to both sides, x equals a negative 5. So these are your two x-intercepts. Okay, so something I want to point out is that this part right here, right, where we have the 2 bracket x plus 2 squared minus 9, in order for this to be proper vertex form, this is not proper vertex form, okay? You would have to distribute this 2 back in. So in order for this to be vertex form, like proper, and for you to tell me the vertex, you would have to multiply that to that. So remember, this is all parentheses squared, right? So you're gonna have 2x plus 2 squared. Nothing complicated, you're just multiplying and putting it in the front. And 2 times negative 9 is negative 18. So now you would be able to tell me the transformation. You can tell me the vertex. You can tell me the axis of symmetry. You would not be able to do that from here because that 2 is out here. Okay, so yeah, that changes things. But because we're finding our solutions, I didn't really care, right? I was able to divide by 2 and just isolate. So your vertex here, what would that be? So here's your H, there's your K. So your vertex would be negative 2, negative 18, which means your axis of symmetry would be at x equals negative 2, right? Do y'all remember that? Compared to the parent function, this 2 is bigger than 1. So that means it would be a vertical stretch by 2. It would shift left 2 units and it would shift down 9. Just a refresher, right? Okay, of what that means. That's just a side note, okay? But if you're just looking for your x-intercepts, you don't have to worry about that. You could have just done what we did originally. Okay, so example 5 is a doozy. So, okay, everyone done with example 4? Okay, first thing, what's wrong with example 5? Well, actually, there's a few things wrong. There's a couple of things wrong with example 5. What's one of them? Uh-huh. Edie, you on top of it today, girl. Okay, so, oh, yep, good job, Emily. So the first thing is that it has to be set equal to 0, right? So we're gonna have 3x squared plus 5x minus 7 equals 0. That was the first thing. The second thing is that a isn't 1. Okay, so example 5 is on here because remember, for the last few lessons, we have been doing different methods to find your solutions, right? Which really just means I'm trying to find my x-intercepts. That's it. So there's methods that I've shown you that work better than others for different cases. Example 5 is an example that I would not want to complete a square. I would not want to do it. Can someone tell me why? Or what's a reason I wouldn't want to do that? Okay, so let's start to solve it and y'all tell me why we wouldn't want to do this, right? First of all, this 3 can't be there, right? So we would have to divide by 3, everything, right? So we're gonna take that 3 out and we're gonna end up with 3 divided by 3 is x squared, which is what we want. But 5 divided by 3, is that a pretty number? Sure ain't. So I'm gonna have to write 5 over 3. You're gonna have to keep it as a fraction. 7 over 3, is that a pretty number? Nope, so you're gonna have to keep it as a fraction again because I don't do decimals, especially not with 3s, right? If I were to do 5 divided by 3, we get 1.66667. Yeah, we're not doing decimals. Y'all should know by now we don't do decimals very often, okay? We're still going to complete the square because I want you to have an example of what that would look like. And I want you to have an example of when I do not want you to do it, okay? You can already see this is going to be ugly, right? And because these aren't even numbers, it's going to be really hard for me to make a model, right? So I can't make a model for this one because they're not pretty, but you can still complete the square. Okay, so how are we going to do that? Well, let's get started. We already know what to do. We know the formula, right? You're going to grab this number and you have to split it into two areas, right? So that does not go away. You're still going to grab your b, divide it by 2 and square it. It's just going to look uglier. So we're going to have 5/3 at the top, and we're going to divide that by 2, and we're going to square it. This is where our middle school skills come in handy, right? Dividing fractions. You should be able to do that. Let me grab an erasable pen. I guess I'll do it in pencil. Whatever I find first. Okay. So this is a middle school review. 5/3 divided by the whole number 2. We know we convert that over 1. To divide fractions, you keep, change, flip. So you keep your 5/3, you change this to a times, and you flip the fraction and multiply. 5 times 1 is 5. 3 times 2 is 6. So we know that this on the inside is going to equal 5/6. Do you see how ugly that is? Okay, just wanted to point that out. So now what? Well, this is these are your sides, right? So now I want to know what number am I going to need to complete the square in here? Okay, well, you're going to square it. So what's 5 squared? 25. What's 6 squared? 36. So you're going to have this 3 on the outside, right? Remember that, because we factored it out of everything. And we're trying to make this into a perfect square. So you're going to have x squared plus 5/3x. What do we need to make it perfect? We need 25/36. This right here is my perfect square. And we have my minus 7/3. But remember, because this is what I need for my perfect square, I have to take away that exact same number from the outside. Sorry, I squeezed it in. That's minus 25/36. This right here is my perfect square, so I can make x plus, we know this is the number I'm going to use, 5/6. And that's my perfect square right there. So negative 7/3 minus 25/36 is actually going to be 109/36. Okay. Yeah, we're going to keep going. It looks ugly though, right? I'd rather factor to find my x-intercepts than do this, but we're going to keep going. Or not even factor. I don't think you would be able to factor. You would have to use a quadratic formula, which is on after the break. Okay, let's keep going. So now we're going to find our solutions, right? So that means that I'm going to have to add that ugly fraction to both sides. So 109/36, which leaves us with x plus 5/6 squared. How do we get rid of the squared? Well, we're going to square root it. The whole thing, right? The entire fraction. So you're going to have x plus 5/6 equals a positive and negative square root of 1/9/36. The process is still the same. It's just uglier numbers. So we're going to have x plus 5/6 equals a positive 109/36, and x plus 5/6 equals a negative square root of 109/36. So you're going to take away 5/6 from both sides. So you're going to have x equals square root of 109 over 36 minus 5 over 6. And you're going to have x equals negative square root of 109 over 36 minus 5 over 6. Now, you should notice that you can simplify this, right? This is essentially the square root of 1 over 9 over the square root of 36. 36 is a perfect square. So I can make that the square root of 36 is really just 6, right? Square root of 36 is 6. So x equals square root of 1 over 9, or actually, I'm going to put the negative 5 in the front. So negative 5 plus square root of 109 all over 6. And this x equals negative 5 minus the square root of 109 all over 6. And we know that because here on the side, so this is like side work, so you can see where that came from. 1 over 9, right? This is the same as saying this, right? Which we know the square root of 36 is really just 6. So that's where this came from, right? And because both of them have a denominator of 6, I can just keep it all under the same 6. So your x-intercepts for this problem is this right here. How do we feel? Number 5 was difficult, right? It was a little annoying. I didn't even want to do it the first time, and I had to do it twice. So, okay, let me stop recording real quick because that's pretty much the end of the lesson.